I welcome you all to today's lesson. So in today's lesson we are going to revise through two topics which are very important, and these topics don't miss in your exams. The first one that we are going to start with is calculus. Then the second one will be functions. So these are the two topics that we are going to discuss. I believe we did calculus, we also did functions. So we are going to revise through these so that we get a full understanding. So this lesson we are going to focus so much on the examination questions that come in an exam. So all the questions that we are going to discuss here, these are the questions that you are going to find in your exams. So let's make sure we pay much attention to this. If possible, make sure you are able to write down all the questions that we are going to solve so that you get to revise at your own time. So this is calculus. These are the questions that you can find under calculus. This is the first part. So these questions are falling under the derivative formula, where you are told to differentiate this by using the derivative formula. So now, how can we go about these questions? I've got the first question. So the first question is saying what? The first question is saying, given that y is equal to 7, find dy dx. How can you find dy dx when y is equal to 7? So for that one, when a number under differentiation, when you are told to differentiate, get this. When you are told to differentiate an expression which is constant, when you are told to differentiate a constant number, the dy dx, so you are going to say dy dx is equal to what? Is equal to 0. So get this, what have I said? Differentiating a constant number is equal to 0. So each time you are told to differentiate a constant number, the answer should be what? 0. Your answer should always be 0 when you are told to differentiate a constant number. So for finding the dy dx of that one, is just dy dx is equal to 0. So that's how you need to go about that one. That's how you need to answer it. So this is how you need to answer it. These are procedures that you need to get. We move to the next one. The next one is saying what? The next one is saying, if y is equal to 5x, find dy dx. In other words, you are told to differentiate that. So there is a general formula that we get to use under differentiation. There is a general formula that you need to know, which is dy dx is equal to nax n minus 1. This is the formula that we normally use whenever we are told to differentiate an expression. N here is the power, a is the coefficient, then the power there n minus 1. So what this means that whenever you are given an expression in an exam, let's say you are given this expression, this is the equation you are given, then you are told to differentiate, which we are doing. So what this means, have you seen the powers come down? Which means that the power which is here, in this case, what's the power there? The power, you know that the power there, it is what? It is 1. You've got 1 as your power. So you say 1 times 5. This is what we are doing. You say 1 times what? 1 times 5. So 1 times 5. Have you seen the power times the coefficient? So in that case, according to the question we are given, we are told to find dy dx. So dy dx is equal to, have you seen? So when you say 1 times 5, what is your answer? 1 times 5, what is your answer? So 1 times what is here? What is your answer? 1 times 5, it is what? 5. Then x comes. Have you seen? A is the coefficient here, which is the 5 there. 1 is the power. So I've just said 1 times 5. This is what I've done. So with this now, I say, okay, the power there, it is what? The power is 1. This same 1, I remove a 1 like that. So which means that I'm going to have an expression which will be like this will be equal to 5x to the power what? Power 0. This is the expression I'm going to have. Have you seen? 5, because 1 minus 1 it is 0. So 5x power 0. This is just the same as 5, because you know that any number raised to the power 0 is equal to 1. So we can just conclude that when you are taught to differentiate, we were taught to differentiate that. This is what we were differentiating. So differentiating that 5x to the power 1, you say 1 times 5, it is a 5. Then x comes, then the power you say minus 1. This is what I did. Minus what? Minus 1. To find the answer there. So which means that differentiating something like that, this is the answer that you are going to get. Have you seen the way the answers come out? So which means that, just to give you a background on this, when you are told, let's say you are given y is equal to 10x, then you are taught to differentiate, meaning dy dx is equal to what? Is equal to 10. This one is just disappearing. With all the procedures that I did there, you are able to understand. Have you seen? You are able to understand all the procedures that I did there. I said 5x, so here to be 10x, 1 minus 1, which will be 10x power 0. Then x power 0 is 1. Then just a 10 will come out. So you can go direct just like that. Once you know that whenever you are given y is equal to 10x, dy dx is just equal to 10. Have you seen? So this is how you need to work out that. I move to this one that is here. I move to this one. So the question is saying, this is how the question is. The question is saying if y is equal to 2x power 4 plus what? 5x cubed minus what? Minus x squared plus 2. This is what I'm given. This is what I'm taught. So how can I go about this? How can I answer this one? So you know the formula that we wrote, this formula. It is the same formula that we'll be using. This is the general formula. Have you seen? This is the what? This is the general formula. So we are going to use this general formula even on this part. So what you are going to say? We are going to say dy dx is equal to, have you seen? This is equal to what? You say this times that. This is what you'll be doing. We are taught to find dy dx. So 4 times 2, it is 8x. 4 minus 1. Have you seen? You remove a 1, then you say plus. What is 5? 3 times 5. 3 times 5, 15. Say 15x. Have you seen? To the power 3 minus 1. You say minus. Here, what number is there? It is 1. So the coefficient is 1. We say 2 times 1, it is 2x. Have you seen? To the power what? 2 minus 1. This is what I'm going to do. This part I'm not going to include it, because I know that if I differentiate 2, what is the answer? The answer that I'm going to get to be what? A 0. So no need of writing that. Then I just conclude and say this is now equal to dy dx is equal to what? What is the answer here? The answer is 8x power what? 4 minus 1, 3. Plus, that is 15x. 3 minus 1, it is 2. Minus 2x power what? Power 1. So even if I don't include the 1 here, this won't matter. Have you seen? So this is how you need to go about any question under calculus. So this is how we work out that question. You've done what? You have differentiated. This is how we get to differentiate. So these are the procedures that you need to follow. This is what you need to get and understand. I want you to understand this. These are the questions that you'll be finding in your exams. So let's make sure we get the concept we understand the topic very well. So let's make sure we understand this clearly and very important. Okay, let us look at the last example under this. The other question which we are given, how can we differentiate this? So when you are taught to find dy dx, it is just the same as differentiating. So how can you differentiate this when you are given something like this? How can you go about this? How can you differentiate? So when you look at this, x is down here as a denominator. Have you seen? So the way it is like this, these two, we cannot differentiate them like this. We need to convert these to negative indices. So you know how to convert from negative index to a positive index. Sometimes the questions will come in this way. So let's just make sure that we understand the concept, we get everything that may come in an exam. So you say y is equal to, you write this expression properly, because the way it is like this, you cannot answer it. You cannot answer it the way it is. So what we are going to do, the way this one is, have you seen? So when it is down here, like the way this one is, 2 over x squared, which means that it is 2x to the power negative 2. This is how it is. So the power will be what? Negative. So it was down positive. So when I change it to a negative index, the power becomes negative. Then I say minus. This will be what? 1 over 2. Then the x will go on top alone. Then it will have negative what? Negative 1. Have you seen? This is how it is going to be. Then this is just one and the same, plus 4x minus 6. That is not changing. So this is how you need to work it out. This is how you need to answer these questions. Have you seen the way I'm answering? This is how you need to work them out. So like this now, you can easily now differentiate. The same concept that we were using, you can use the same concept to differentiate this. So I want you to understand this, and I want you to get the concept how we can go about this. So changing, so when you're given a number, let's say you're given a number like x to the power negative 2. Changing this to a positive index, this will be 1 over x power 2. Have you seen? On top there 1, because we don't have anything. But if we add a 10 there like this, 10x to the power negative 2, meaning here we were supposed to have a 10 like this, 10 will remain. Have you seen? So this is how we get to change from a negative index, from a negative index to a positive, or from positive to negative. This is how you need to do them. Then you do the usual thing of multiplying. So I'm going to do the usual thing of multiplying now. So I'm going to say dy dx is equal to, you say negative 2 times 2. This is negative 4x power negative 2 minus 1. Negative 1 is part of the formula. Have you seen? Then you say negative 1 times negative half. That is positive 1 over 2. That is 1. So only the sign is going to change. Negative times negative, it is positive. Then x to the power what? Negative 1 minus 1. This is what you are going to do. So these are the procedures you are going to follow. Then you say plus. Here we've got a 1 there. 1 times 4, it is 4x. Then 1 minus 1. Have you seen? Then I told you that we cannot differentiate a constant number. So there you can put plus 0, or you just leave it. You cannot differentiate this one. Negative 6 cannot be differentiated. Why? Because it is a constant number. So we don't differentiate constant numbers. I want you to get this. We don't differentiate constant numbers. So just say this is now dy dx is equal to, so this is what? This one will become what? Negative 4x to the power what? Negative 3. Then you say plus 1 over 2x to the power what? Negative 2. We are just adding. Have you seen? So same signs you add, then that one becomes plus. What answer is going to be there? So this one, I've already told you the way it is going to be 4x power 0. Then which means that this will just be what? A 4. So that one will just be what? A 4, like that. So if you want, you can end here where I've ended. There is no problem. If you don't know how to change from negative to positive, end here. Because if you continue, you may make you can mess up things. So let's just know our capacities. You know that okay, me I cannot proceed from here. So you can just end here. It is okay. They are going to mark you in an exam. So when you do that, then you say, but if you know what you're doing, you can finish up this. You can say dy dx is equal to negative 4 over x power 3. This is how it is going to be. Then you say plus what? 1 over 2x squared. This is how it is going to be, like that. Then you just say plus what? Plus a 4 there. Then you are done. So I've changed everything. So negative 4 over x to the power 3 plus 1 over 2x squared plus 4. I've changed. So I will say O. If you want, you O, this answer and this, they are just the same. So if you don't know how to change this, you can just end there. But if you know what you're doing, you need to proceed till you reach that step. That's how we need to work out these. This is how you need to answer them. Okay, so let us move to the other part. We move to the other part. So let us look at this other one. So I'm going to end with this, and when you're told to differentiate, then I give you an exercise before we proceed to functions. So I'm going to give you this one. Okay, so it is saying that given that y is equal to 2 open bracket 4x minus 1 close to the power 3, find dy dx. How can you answer this one? So first thing, before you answer this one, whenever you see a question under this in mathematics, in under calculus, just know that this is falling under what? Chain rule. So it is falling under which rule? That is what? That is chain rule. This is how a chain rule question looks like. So any question that will be like this is falling under what? Chain rule. This is the chain rule. So we are going to use the chain rule to differentiate that. And how do we use the chain rule to differentiate that? The first thing you are going to say let. So we are going to say let u represent what is in the brackets. Represent what is in the what? Brackets. So in the brackets we've got 4x minus 1. That is in the brackets. Then you say and, meaning when you say y will be equal to what? Y, we've got a 2 there which is outside. This one has changed. This is no longer 4x minus 1, but it is what? U. So you're going to put a u there. Then you say power what? 3. This is what you are going to do. So that is what you are going to form. That is what you are going to form. So with this now, what is the next thing that you are going to do? You are going to differentiate this one, then you differentiate that one, then you multiply them. You are done. So this is how we get, using the same concept that we were using. So this one, it is not dy dx, but it is du dx. Why? Because we are having what? We are having u and x. So du dx. Then in the previous examples that we from having, I said that this one, -1, you cannot differentiate it. So just leave it like that. That one, you cannot differentiate it. You go to 4x. 4x, how do we differentiate 4x? The answer is 4. Have you seen? I told you how we differentiate this. So previous lessons, previous example that I gave. I was saying 4x, that one was something like, if you are given a number like 10x, the answer will be 10. So this is what I've used here. I move here. So this one here, I'm differentiating what? dy du. Have you seen? dy du. This is equal to. So you say, you multiply the same thing we were doing. So you say, this times that, 3 times 2, that is 6 u. Have you seen? Then the power there, you remove 1. So let us remove 1. When you remove 1, you are going to have what? A 2. Hope no one is lost here. So the previous examples that we from doing, this is how we were doing these things. So this is how you also need to do them. Just make sure that you understood the first part, which I was saying. So this is how we need to work them out. Let's make sure we understand this. We revise through all these things. So when you do this, then you just say, then the formula dy dx is equal to, this is the formula that we use. We say dy du times what? Times du dx. This is the formula that you are going to use, which means you just multiply these two. You just do what? You say this is equal to, you just multiply. So dy du, it is here. Dy du, it is here. It is what? 6 x power what? Power 2 times what? Du dx. Du dx. Where is du dx? It is here. Du dx. So you bring a 4 there. Have you seen? So then the answer that you are going to get, this is equal to, what is 4 times 6? 4 times 6, it is 24. 24u squared. So this is your what? This is your answer. You say dy, then here you put dx like that. Dy dx. So now, where there is u, you can remove this. You said u was equal to what? Here, u was equal to 4x minus 1. Then you just say 24, open bracket. Where there is u, you say 4x minus 1 cross to the power what? Power 2. You just put a 2 there. So this is what? This is your answer. This is how you need to differentiate. That is how we differentiate that. So these are procedures you need to follow. These are procedures that you need to understand. So let's make sure we get this. We understand all these procedures that I'm telling you. I'm making calculus very simple so that when you encounter such a question in an exam, you won't fail. So let's make sure that we get the concept here. And I believe you're able to write down everything that I'm doing here. You're able to write down everything that I'm doing here. So let me give you an exercise that you are going to do before we proceed to the other part. So you are going to copy this exercise in your book. Then when the lesson is done, that's when you'll be able to write it. Not now. Just copy down the exercise. You copy down the exercise. Then after, when the lesson is done, that's when you answer all the exercise that I'm going to give in this lesson. So exercise 1, this is your exercise 1, just for you to practice. So this is the exercise. This is the exercise. This is the exercise. Find dy dx of the following. So these are the question 1. Is saying y is equal to 4x to the power negative 2 minus 4 over x. We've got the second one. So these are the question. Hope my handwriting is very clear. You are able to see. You see what I've written here. So hope my handwriting is very clear. You are able to see what I've written. Hope you are able to get what I've written. This is what you need to understand. This is what you need to get. So these are the questions. Copy them down. So copy these questions in your book. Copy these questions in your book. Copy this question in your book. You are going to submit this week. You are going to submit this week. So we are going to do this. week. So these are the questions that we need to practice. This is our practice questions. Let's make sure that we practice them, and I believe we've understood the concept, everything that I was trying to work out. So let's make sure that we answer this. We answer all these questions and submit. Okay, so we move. We go to the other part of this. So we move to the other part of this tutorial. Okay, so we move to the other part of this lesson. So let us now move to the other part. Hope you've written down these questions. This is the question that we are going to move to. This is our next question. The question is saying find the equation of the normal and tangent to the curve y is equal to 3x squared plus 4x plus 1 at the point x is equal to 4. So this is the question which we are given. So what are we told? We are told to find the equation of the normal and the equation of the tangent. These are questions that usually come in an exam. So make sure you pay attention to this, how I'm going to solve this. Make sure that you understand this question clearly. So the first thing that you need to do, you ask yourself at the point where you are given x is what? X is 4. So you ask yourself, do you have the corresponding value of y? The answer is no. So if you don't have the corresponding value of y, if you are not given a coordinate, then which means you need to find the value of y. That is the first thing that you need to do. You find the value of what? You find the value of y, the corresponding value for y. So how do we find the corresponding value for y? So the corresponding value for y, it can be found where we get this value of x, replace in this equation. This is what you are going to do. So you get this, you say y is equal to, so where there is x here, you are going to put a 4 there. So you are going to say 3, then 4 squared plus 4 plus 1. So I've put a 4 there. That is what you are going to do. So you say y is equal to what? This is 3 multiplied by 16 plus 16 plus 1, like this. 4 to the power 2, it is 16. Have you seen? So this is what you need to do. This is what you need to get. So these are the procedures you need to do. This is what you need to get. So you say y is equal to, you get to find the what? You get to find the answer now. This is, so when you multiply everything here, you use your calculator. This is 17. Have you seen? This is 17. So that is 17. You are going to get a 17 here. This is 48. So 48. So what is your answer when you add? So when you add here, we are going to get 15. 5 remainder 1. This is 5 plus 1, 60. So we are going to get a 65. Have you seen? So this is y is equal to 65. So since we found the value of y, which is 65, which means that a coordinate that we are having, a coordinate. So what is the point? So the point is what? The point now should be 4, 65. This is a what? This is a coordinate that we found. So this is a coordinate that we've found. This coordinate. So after you find a coordinate, the first thing that you are going to find is the equation of the tangent. That one is very simple. So we are going to start with the equation of the tangent. So how do you find the equation of the tangent? First thing, we need to do what? We need to differentiate what we are given. So we are going to say dy dx is equal to what? Dy dx is equal to what? You differentiate what is given. So you need to differentiate what is given. So what are you given? You are given this equation. You differentiate it. You say this times that, then x, then that one minus 1. So we are going to have 6x. Have you seen? Then plus what? Plus 4. That is what you are going to have if you differentiate that one. Have you seen? Like this, plus a 4 here. You know that you cannot differentiate a 1 there. You cannot differentiate a constant number. You can't differentiate a constant number. So the 1, you just leave it like that. Then 4x, I told you that when you differentiate that, it is just the same as a 4 there. So this is how we need to differentiate that. Then you know that dy dx, it is just the same as the what? It is just the same as the gradient. So where there is dy dx, you put gradient. You say this is m is now equal to 6x plus 4, like this. You find the what? You find the gradient. You just find the what? You just find the gradient. Which means that you say gradient is now equal to where there is x, you put a coordinate which was given in the question, which was a 4 there. We've got a 4 there. So I'm going to have 6 like this, 4, then plus 4 there. This is what I'm going to have. So where I'm going to say gradient is now equal to, what is 6 times 4? This is 24. Plus 4, you're going to get 28. So which means that your gradient is what? Your gradient is 28. So once you've got this gradient and this point, then we can find the equation of the tangent. That is very simple. So how do you find the equation of the tangent? How can you find the equation of the tangent? Just find the gradient and a point. So this is the gradient we are given, and this is a point. So when these two, the same way I've done, and you've got this one here, just find the tangent. You can find the tangent. So how do you find the tangent? Differentiate. When you differentiate, you find the gradient. After finding the gradient, you check, do you have a point? Some questions will be given this point, so no need of doing these calculations. Some questions, they are going to give you that point. So now you say, okay, I've got this point and that one. I can find the equation of the what? Tangent. So you just find the equation of the tangent. So you write the formula. What is the formula? Which formula are you going to use? The formula is y minus y1, which is equal to gradient, open bracket, x minus x1. This is the formula that you are going to use. So we are finding the equation of the tangent. We haven't started finding the equation of the norm. So I'm just showing you how you can find the equation of the what? Tangent. So you find the equation of the tangent just like this. You say, okay, y, this one is constant, so to maintain y, then you say minus, what is y1? This is x1, this is y1. y1 is what? 60 what? 65. This is equal to, so this is equal to, what is your gradient? Our gradient was what? 28. You do this. What is x? X there is constant. Minus, what is your x1? It is 4. You just do that. You say this negative 65 will go to the other side of the equation, which means you are going to have y is equal to, what is 28 times x? It is 28x minus, this is what you are going to do. So these are the procedures that we are going to do. So these are the procedures that we need. So 28 times 4. What answer are you getting? So confirm with me the answer there. So what answer are you going to get? What answer are you getting when you multiply there? What answer are we getting? We are getting 112, right? Multiply. This is paper 2. Such questions, the equation of the norm and tangent comes in paper 2. So you are allowed to use a calculator. So it is, you find the what? You're going to find a 112. So you say 112. 112. Have you seen 112? Plus this one that came this side. So when it comes this side, it becomes plus. Plus what? Plus 65. This is what you are going to get. So that is what you are going to have, just like that. Meaning that the answer that you are going to form, the answer that will be formed. The answer, okay, let me do this. Just use 2 papers. Okay, like this. The answer that will be formed, the answer that you are going to form, this will be your answer. You say y is equal to, this will maintain 28x, like this, 28x. So what is the answer there? When you say negative 112 plus 65, confirm with me. This is minus 47. So let's be working this together. Maybe if I haven't calculated well here. What is negative 112 plus 65? So once we find this, this is called now, what is this? What is this? This is called the equation. Have you seen? You just say this is equation of the tangent. Equation of the tangent. This is how you find the equation of the tangent. Have you seen? So this is the equation of the tangent. This is how you need to do it. So this is the equation of the tangent. We found the equation of the what? Equation of the tangent. So now, how do you find now equation of the normal? This is the next question that you need to have. How do you find the equation of the normal? How can you find the equation of the normal? So I'm going to start from here. I'm going to show you how now you can find the equation of the normal. This is very simple also. This is very simple. I'm going to start from here. So I'm going to do this. I start from here like this. So how do you find the equation of the normal? You get this gradient. This is the gradient. So here, I want to find the equation. I'm going to say equation of the normal. I want to find the equation of the normal. This is what we want to find. Equation of the what? Equation of the normal. So how do you find the equation of the normal? You say that gradient 1 times gradient 2, you must get negative 1. So the equation of the normal and the equation of the tangent are perpendicular to each other. When you multiply their gradient, you must get negative 1. Which means that what I'm going to do here, I've got the first gradient. The first gradient was what? 28. So 28 m2 is equal to negative 1. I'm finding m2. So I say over 28, even here over what? Over 28. So which means that m2 is equal to negative 1 over 28. This is now the gradient that I'm going to use for equation of the normal. So equation of the normal, you find m2. But equation of the tangent, you just use the same gradient that you found. So these are the procedures that you need to do like this. Then everything becomes simple. You just say, oh, I'm done now. So what am I going to do here? What I'm going to do now, I just write the I know that the point is that one. Have you seen? That is the what? That is the point which I'm given. I'm given that point. So what I'm going to do, I'll just say, okay, I'll just say y minus y1, which is equal to m, open bracket, like this. I say x minus x1. This is what I'm going to use. So I just say y minus, what is my y1? We use the same coordinate. Y1 was 65. So the same one, 65, which is equal to, what is gradient? Negative 1 over 28. I say this is x minus, what is my x1? X1, you check 4. So you put a 4 there. You do this. Then you work out this part. You work out this part. You say, okay, this one will go to the other side. You say y is equal to negative 1 over 28. You are multiplying by x, so the x will maintain. Negative times negative, the negative there, and this negative, this one becomes positive. Positive what? Positive, so I'm going to have negative 1 times 4. So 4 over what? Over 28. This one, when it comes this side, I'm going to have plus. Plus what? What am I going to have? This is what I'm going to have. I'm going to have plus 6, 5, like that. So this is what I need to do. I say now, finally, the equation of the normal is equal to. So here, what's the answer? Here, this one will maintain like this x. But when I type this one on my calculator, when I calculate this one, I say 4 over 28 plus 60, 65. What answer am I going to get? I'm going to get plus what? Plus 456 over 7. This is your answer. This is the answer that you need to get. So this is our what? This is our answer. So maybe you can find something like this. I know when you type that, if you find your answer like 1, then you see this 1, 1, then 2. This means that 1 whole number, then 1 over 2. You are able to change that. You say this times that, this is just equal to, they are just the same as this times that, 2 times 1, 1, plus 1, 3. So just same as 3 over 2. So these two are just the same. So if you found something like this on your calculator, you just do that, then you get that as your answer. Just one and the same. So this is the equation of the what? This is our equation of the normal. This is our equation of the normal. This is equation of the normal. This is how we find the equation of the normal. Equation of the what? Equation of the normal. Equation of the normal, like this. This is how we calculate the equation of the normal. So let's make sure that we revise this. We know how to go about these questions, how you can answer them. Let me give you an exercise on this, how I see how you are going to answer it. So this is exercise 2. Hope you are counting. Exercise what? Exercise 2. This is our exercise 2. Hope you are counting. You are writing down these questions. Let us go to exercise 2. The exercise 2, which is saying find the equation of the normal and tangent to the curve. To the curve. Which curve? This is the curve which is given. This is our curve, which is y is equals to x squared over 4 at the point 6, 9. So just to give you an hint on how to go about this question, you are told that the point is given, so no need of finding y because it is already what? It is already given. That thing is already given. It is already given. So now we say this is what we are going to do now. You differentiate first. After differentiate, you find the gradient for tangent, then gradient for normal. When you are done with that, that's when now you can proceed. So you say find the equation of the normal and tangent to the curve. Y is equal to x squared over 4 at the point 6, 9. This is your exercise 2. This is your exercise 2. So all these are examination standard questions. I'm getting these from different past papers and specimen. So let's make sure that we revise through all these. We answer them correctly. We see how we can handle these. So equation of the normal and the equation of the tangent. These are the questions which are there. So let's make sure that we revise through this, we understand them. So let us now start functions. Let us start now functions. We need to go now to functions, how we can answer some questions under function. So let us see how we are going to go about this one, how we are going to answer this question even as we proceed to function. So today you are going to have a lot of assignments to do because exams are approaching. So we need to make sure that we know how to answer these, we know how to go about all these questions that are here. So let's make sure that we answer this week, we revise through. Hope everything here you are writing down these things. I'm slow here so that even as I'm talking like this, you are able to copy down this question. You are able to copy down this question. So I want you to answer this week. So let us now move to functions. Let us revise through some questions under functions. Okay. We start functions. Let us revise through functions now. So these are the questions that we are given under functions. It is saying that, so if you go through past papers, you can tell This is a 2016 specimen question that came in. This is the question that came. So you are able to tell these are the questions that came. So this is the question that we are having here. How can we go about this question? How can we answer it? How can we answer them? So, first question, given that f of x is equal to 2x minus 3 and g of x is equal to 3x plus 1 over x plus 2, find the f inverse of x. This is the first question. The second question, we are told f inverse of 11. Then the third question, we are told to find g f of x. These are called composite functions. So these are called composite functions. So how can we answer this question? How can you answer this question? The first question, I'm going to start with the first question. We are told to find f inverse of x. How can you find that one? How can you answer that one? The function f, where is the function f? F of x, the function f of x is equal to 2x minus 3. That is the function. Have you seen? Then from here, where there is f of x here, you put y. So this is y is equal to 2x minus 3, like this. This is what you are going to do. Then from here, you make x the subject of the formula. So you need to make sure that you make x the subject of the formula. So it is going to be y when 3 will go this other side. So plus 3. You know that when 3 goes this other side, the sign will change. 2x. Have you seen? Like this. Then we divide both sides by what? Both sides by 2. Here by 2, even there by 2. This cancelled. So x is now equal to what? Y plus 3 over what? Over 2. This is the answer. Have you seen the way I've answered this? This is how you need to answer it. Then you just conclude and say, therefore, f inverse. So therefore, f inverse of x is equal to. Now, where there is y there, you put x. So this is x plus 3 over 2. This is your answer. This is how you need to answer that one. So you've answered the first part of the question. This is how you need to answer that first part. I move to the next part. So I move to the next part. Next part, question B. So question B, I'm told to find f inverse of 11. Have you seen? So before you find this one, you need to ask yourself, do you have the inverse of f? The question is yes. This same one that you from finding this one here. This is the same one you're going to use. So you're going to say f inverse of x is equal to what? Is equal to what? X plus 3 over 2. This is what you are going to do. Where you are going to say that f inverse of what? 11 is equal to, you put 11, which means that where there is x there, you are going to put 11. So it is 11 plus 3 over 2. This is what we are going to do. Then finally you say the f inverse of 11 is equal to what? This is now equal to what? This is equal to what? So what you are going to do now is, what is 11 plus 3? That is 14. 14 divided by 2. It is 7. It is what? 7. So this is your what? This is your answer. 7. You know that when you add there, you get 14. 14 divided by 2, you are going to get a 7. So f inverse of 11, that is a 7 there. That's how you need to answer this question. This is how you need to go about that part. I move to this one now. I move to this question, which is here. So I move to this one here, this other question. So this is the question that now I'm told. This is the question that I'm now told. So in this question now, it is saying g f of x. These are called composite functions, where you are told to combine two functions. So they are called composite functions because you are going to combine two functions. So you are going to combine two functions, which is the function of g and the function f. So you always start with what is given. What is given, it is g. So you say, what is g function? G of x is equal to, you write that one. What is g of x? It is there. It is what? 3x plus 1 over x plus 2. This is what you are going to do. Have you seen you? Then they have also included this other function, which is f. So I'm going to say g f of x now. So I'm going to combine two functions now. So how do we combine two functions? The second one is f. So here, have you seen here where there is x? Just concentrate on the x. Here where there is x here, that's where I'm going to put this function there. Have you seen? So the function there, it is what? 2x minus 3. So here where there is x, I'm going to put 2x minus 3. Even here where there is x, I'm going to put what? I'm going to put 2x minus 3. This is what I'm going to do. So this means that I'm going to have what? 3 open bracket. Then I put 2x minus 3. I cross. Then I say plus 1 that is there. Say plus 1. So what I've just changed here where there is this part, I've just put 2x minus 3. Where at x there? Because I'm combining two functions. Then I say over. Over what? What is x plus 2? What is x plus 2? Ex plus 2. Where there is x, you also put that function. That function, that is the function you are given. So you're going to put that function where there is x. You say 2x minus 3. You've put that. Then you've got a plus 2 here, which is on the formula. Plus 2. With this now, where you are going to say that now, g f of x is equal to, so what is, you work out this part. So what is the answer? 3 times 2x. 3 times 2x, that is 6x. 3 times 3, that is minus 9. Then you say plus 1. Over. Over what? Here, it is 2x. We are going to say 2x. Then negative 3 plus 2, that is negative 1. That is the answer you are going to have. Where you are going to say now, you are going to say now, therefore, g f of x is equal to, so it is equal to what? This one is equal to what? You say 6x. What is negative 9 plus 1? Negative 9 plus 1. It is what? Negative 8. So it is negative what? Negative 8. You say over. Over down we've got what? 2x minus 1. So that is your what? Your answer. This is how you need to work out that. Have you seen? That is the answer that you need to get. So you need to make sure that you have that answer. This is how we need to go about this. This is how you need to answer this. So this is how we need to work out all these calculations that I've just done. Let us look at another example here on functions. So functions, they are just the same. That's why we won't focus so much on this, because even yesterday I did something under functions. So I believe we revise through. Even here, I'm not going to focus so much on questions under functions. So let me give you another example, which happens to be our example 2. The next example that we are going to do, this is our next example, which is saying given that f of x is equal to 3 over 2x plus 1 and g of x is equal to x plus 2. This is what we are given. Then the first question is saying find fg of x and fg of 2. This one is very simple, so I'm going to answer it for you. we are going to revise this together. We see how we are going to go about this. We see how we are going to answer them. So how can we answer such a question? So these are composite functions. These are what? Composite functions. So how can you answer these composite functions? What you are going to do is this. This is what we are going to do. So we are going to do this. We are going to say that the function here, fg, we are combining two functions. So I'm going to start with the function f, the one that I've started with. So f of x is equal to what? 3 over 2x plus 1. This is the way it is. Then they have also included which function? The function g. Where is the function g? That is the function g. This is the function g. Meaning that I'm going to say f of x, f of x, I know that it is that. So I'm going to say f, I put g because I'm combining it with that other function. Then I say x, which is equal to 3 over. Meaning that here where there is x, here where I've got this x, that's where I'm going to put that function, which is x plus 2. Have you seen? So just here where there is x, so I'm going to say it is 2 open bracket. So I'm going to say x plus what? Plus 2 close. Then I've got a plus 1 here, plus 1. So I'm going to say plus 1. So this is x, that is here. Where there is x, that's where I've put the function g, so that it can fit in this expression. Then I say f g of x is now equal to what? 3 over what? What is 2 times x? It is 2x. What is 2 times 2? That is a 4. Then I say plus the 1 there. Then finally I'm going to have my answers. F g of x is equal to 3 over 2x there, then plus what? What is the answer? What answer I'm going to get there? 4 plus 1, 5. I'm going to get a 5. So this is how I need to work out that one. So this one here, this is my answer. Have you seen? This is my what? This is my answer. This is how I need to answer that one. I move to this other one. What am I told in this other question? What am I told? I'm told to find what? I'm told to find fg of 2. So I want to find fg of 2. How can I find that? So you ask yourself, do you have fg of x? Do you have that? Yes. The same one from finding here. If you don't have, you need to do all these procedures. So which is 3 over what? 3 over 2x plus 5, like this. This is how you need to do it. Then you say fg. Now where there is x there, they have put a 2. So you're going to put a 2, meaning that even here where there is x, you put 2. 3 over 2 times 2 plus 5. This is what you're going to do. We are going to say fg of 2 is equal to 3 over, what is 2 times 2? 4. 4 plus 5, it is 9. 3 over 9. Then just conclude. Therefore, fg of 2 is equal to 3 there, it is 1. 3 there, it is 3. So 1 over what? 1 over 3 is your answer. That's how you need to answer that one. These are the procedures that you need to follow. This is what you need to get and understand. So let's make sure we revise through this. We answer questions that may try to come under functions. So this is very simple. I believe you are able to understand from here. You are able to answer 1 or 2 questions. So this is what you need to do. This is what you need to get. So with this now, you can't fail any question that may try to come under functions. So let's make sure that we revise through functions. So if you haven't gotten the concept under functions, let me know so that we see how we can do it. So just notify me I see that a lot have not understood on these functions. We see how we can go about this so that everyone gets to understand. So let me not give you a lot of lessons. Let me not give you a lot of examples. So let me give you a question. I see now if we've understood this. Let me give you a question which you are going to answer. I see if we have understood. This is the question that I want you to find. Given that f of x is equals to 5x over x minus 1, then find f of 6, find f inverse of x. The last one, find the value of x for which f of x is equal to 0. So these are the questions I want you to practice. This is what I want you to answer. So let's make sure we answer this, we revise through this. I'll be waiting to get your answers. So this is exercise, another exercise which I've given you. If I'm not mistaken, this is exercise 3. This is exercise 3. So let's make sure we answer this, we revise through all these things that I've given you. So let's make sure we work this out, we understand them. So copy down this question. This is exercise 3. So I've given you a lot of exercise today so that we practice through, we understand everything that needs to be covered. So understand this clearly. Each and every question that may come in an exam, you are able to answer it. Thank you so much. So, like I've been always saying, this is my official YouTube channel. So, if you are under me, you need to make sure that you've subscribed to this YouTube channel. Let's make sure that we all subscribe to this channel. So each and every video that I get to post, you like the video, you comment. So make sure you like and press a comment according to how you've understood this. So I'm waiting for the work in my inbox. Everyone should participate. I see how we are improving. Thank you so much.